Michio, the floor is yours.
Down, you can. Нам нужно микрофон, если есть, тогда ручка.
We need a mic for Miko.
Or we can use. У нас есть микрофон ручной у кого-то?
Do you have a roaring mic?
Thank you for such a great introduction. I can't wait to hear the speaker myself. First of all, let me quote from a quantum physicist who predicted the future, Niels Bohr. Niels Bohr once said, quote, "Prediction is awfully hard to do, especially if it's about the future." Well, let me say some things about the future. In the future, would you buy a computer which is just as fast as the previous year's computer? Would you buy an iPhone knowing that it's no more powerful than last year's iPhone? And you may say to yourself, no, why should I upgrade? Why should I buy the latest version of anything if it's identical to last year's model? Well, that's the problem. Our digital society is based on Moore's law, that computer power doubles every 18 months. But as George Harrison of the Beatles once said, quote, "All things must pass, including Moore's law." And when that happens, we could have a global recession. The fate of nations could rise and fall if Moore's law falls. Already, we see that Moore's law is flattening out. It's slowing down. Next year, at Christmas time, your presents are not going to be twice as powerful as they were the previous Christmas. We are entering the end of the age of silicon. We're going to be entering the post-silicon era. And there could be massive disruption. Who wants to buy a computer anymore, knowing it's the same as last year's model? Silicon Valley, the envy of nations around the world. Silicon Valley could become a rust belt. Think of that. Unemployment, devastation, people out of work in Silicon Valley. Why? Your Pentium chip today has a layer about 20 atoms across. The Pentium chip that you hold in your hand, 20 atoms across. In 10, 15 years, it's going to be 5 atoms across. At that point, quantum mechanics takes over. The Heisenberg uncertainty principle takes over. You don't know where the electron is anymore if your Pentium chip has a layer 5 atoms across. Leakage, heat, all these things destroy Moore's law. What we need is a replacement, because this will determine the next Silicon Valley. I repeat, the next Silicon Valley will be determined by who can create a successor to silicon. Now, in some sense, this is very similar to what happened 100 years ago with the invention of the light bulb. You see, 100 years ago, we knew the laws of electricity. Faraday, Maxwell worked out the laws. It was an engineering problem for people like Edison to try hundreds of different chemicals, trial and error, until they finally found tungsten, which makes light bulbs possible. The physics was known. The engineering was not. Today, we know the physics of quantum computers. Atoms, for example, can spin up in a magnetic field, or they can spin down. If they spin up, we can say this is a 0. If they spin down, this is a 1. This is how we can put digital on atoms. But you see, atoms are much cleverer than that. They can not only be up or down, they can be anywhere in between. This means that quantum computers are almost infinitely more powerful in principle than what you can do with zeros and ones. This is the reason why some of the biggest names in the digital revolution are jumping on the bandwagon. Google is now investing in superconducting qubits. These things that go up or down or in between are called qubits, quantum bits. So Google has entered the picture. Microsoft is backing a dark horse, topological qubits. So Microsoft is jumping into the game. Intel, a master of silicon, is using silicon quantum dot technology to create quantum computers. IonQ is using ion traps. 5 different versions of quantum computers, just like what happened 100 years ago. Now, who is going to win this race? Well, it was not clear that Edison and his colleagues would win the race for a light bulb. It was trial and error. We are in that realm today. It could take decades. It could take tomorrow, or it could take decades, just like with Edison. As Edison once said, genius is 1% inspiration, 99% perspiration. And now let me say a few things about what you can do with a quantum computer. First of all, the tipping point is 49 qubits. If you can create a quantum computer with 49 qubits, you're now neck and neck with ordinary digital computers using Pentium chips. 49 qubits is what you need. But beyond that, we can now begin to model quantum processes like chemistry. Chemistry is built on quantum mechanics, the mechanics of atoms, atomic physics. But we don't know how to model them. They're too complicated. For example, photosynthesis. Something as basic as photosynthesis, we don't know how to model using pure mathematics. Or, for example, Alzheimer's. Some people think that the Alzheimer's molecule, the amyloid protein, is created by folding incorrectly. And that's why millions of people go crazy. But no computer is powerful enough to model the folding of the prions that some people think is responsible for Alzheimer's disease. What I'm talking about is doing chemistry from first principles. Chemistry reduced to software so that we don't have to play with thousands of different kinds of antibiotics, thousands of kinds of plastics, thousands of different kinds of chemicals. We can do it using software in a quantum computer. As you can see, this could change everything. Not only that, but the next big science project is the Connectome Project. The Manhattan Project gave us the atomic bomb. The Genome Project gave us the human genome. The third great initiative could be the Connectome Project, to map the entire human brain. And that may take a quantum computer. And this means that in the future, communications could be done mentally. What I'm saying is that the internet will be replaced by BrainNet. We will send emotions, feelings, memories on the internet. The first memories in animals was sent on the internet 2 years ago. 2 years ago, we can now upload memories, simple ones, and download memories in mice. Now we're doing it with chimpanzees and apes. Next will be Alzheimer's patients. Alzheimer's patients will have a chip. You push the chip, and all of a sudden, memories go floating into their hippocampus. This may be the way that we communicate with our fellow human beings via the internet, via a new form of the internet called BrainNet. So we're talking about a new revolution in science. The next revolution is artificial intelligence. Some people think that artificial intelligence is the fourth wave of wealth generation. The first wave was steam power, which gave us the Industrial Revolution. The second wave is electricity, giving us the electric revolution. The third wave is the transistor and high technology, giving us the digital revolution. The fourth wave of wealth generation, the fourth wave could be artificial intelligence, biotech, and nanotech. And what unites all three could be quantum computers. Now, some people think, well, gee, can computers get... Oh, I think I'm running out of time, so sorry about that. But anyway, this is just the beginning of the story. When will we have quantum computers? If I knew the answer to that, I would be a billionaire. Sorry about that.
Thank you very much. А, Так интересно, что я
It was so interesting that I actually was trying not to interrupt you. Certainly the world will change, but in order to make this world change tomorrow, we need, Miko already said about the superconductive circuits, about the quantum computers by Google, and I would like to give a very complicated task to Alexei Ustin, who is a professor at the Karlsruhe Institute of Technology, and he is also heading a group in the Quantum Center. He has 5 minutes to tell us what is the difference between the quantum computer from the conventional one. If you have a 2-qubit, is it a computer, or do we need a 49 qubits to consider that this is a quantum computer? You have 5 minutes to speak, Alexei. Thank you, Ruslan. It was a brilliant speech by Professor Kaku. It was already said that the superconducting circuits are the main essential element of quantum computing. I think I'm not able to tell you what a quantum computer is within these 5 minutes, but the previous speaker already said that a quantum computer is a device operating not on conventional digital bits, but in between zeros and ones, which can be in every single proportion with the different phases, and they can participate with it in a computing. So we have really an unlimited opportunity to present the information in this case. And the revolution which is taking place today started with technology, as every single revolution. Probably 15 years ago we started having the first research in artificial quantum systems, what was already mentioned by the previous speakers. It was already said about the Moore principles, which is also well known in the semiconductors, which also foresees how to double the speed of processor or how to use the transistors. And this Moore's principle is have been already used in the superconducting technology in these superqubits. Because if we talk about the coherent time, well, that's the time where the quantum state lives, because it should exist. So this coherent time increased by 1,000,000 times, and that is a certain change which already influenced Google and Intel. And Intel works not only on the semiconducting and superconducting qubits, and all these companies, including IBM, chose the superconducting technologies. And there is another company which is already selling these superconducting computers, and this computer doesn't resolve all the tasks which it is supposed to resolve. And the next question, Ruslan asked me to comment very briefly, what is a computer? And certainly a user identifies everything, because the first chips which were made of several transistors, they were not really interesting for consumers, but when it became possible actually to unite thousands of transistors on one board, we were able to create a very complicated device which was not really clear in the beginning, but these devices created the new technology, and now the semiconductor computers with the 17 qubits at Intel, or 16 qubits at IBM, or 49 qubits which Google is intending to achieve. And John Martinez, or the guest of the Russian Quantum Center, because this year in Moscow, he promised to create a 49 qubit computer by the end of this year. So it will be able actually to do the computation really up to the limit, and even will be more powerful than the whole computing capacity of the Earth. That's the answer within these 5 minutes given. Thank you very much. Thank you very much, Alexei. If we keep talking about technologies more, so we start talking about the quantum computers we're only dreaming of, we can go back to quantum communications, which already exist in Russia, but the Russian Quantum Center already started dealing with them, but also there is a group at the Lomonosov University of Moscow dealing with it. So I would like to ask Sergey Kulik, who is a professor at the Lomonosov University of Moscow, what are we doing in Moscow? Do we need a secure connection? How can we do it?
I would like to look at this problem a little bit wider. Modern quantum technologies and the science about quantum information processing has three pillars, and one of them is presented here: quantum computations and quantum communications. I will speak about quantum communications, and the problem I will verbalize it in 4 levels. Like any problem, it's multi-level problem. Level number 4 was developed about 20-30 years ago in Soviet school, Russian quantum optics, and right now it's adopted and perceived in the world, and main skills of the scientists about how to prepare non-classical components, how to transfer and transform them and manipulate with this data, and how to measure it. It was known a long time ago. And how to process this data statistically. It was developed back then. Then engineers came to the market. The engineers, they create machines. Those first machines were developed back then. And right now I'm speaking about the topic what I was asked to speak about: quantum cryptography. Machines which give to legitimate users crypto keys. And in this place, unfortunately, I would like to say that we have to draw a line. These machines were created, demonstrational machines. Some went even further, went into commerce. Some of them went even to serious organizations. But in our country, this level is limited only by experiments. A bright example was shown. Device which was called quantum phone. But why? Well, this is cool, but why do we need it? And then level number 3 comes to the view. I call it a client's level. When people come who really need it, and they can tell you why do they need it, when they need it, which parameters are needed as well. And this level is a very serious level, and we're trying to pull up to this level, and it will define the potential of the development of these particular quantum technologies, especially in the area of the most advanced quantum telecommunications. Level number 4. This is also a very important level, and this is specifics of quantum technologies. Fortunately, it's educational level, because in order to work with all of this, starting with people who've been researching, engineers who've been making machines, and then client formulates his requirements for this, well, for this you need a lot of and powerful educational layer, which is not going to be laid by a number of lectures, not 30-minute discussions in an attempt to tell what it's all about, photons or qubits. It's a course, normal physical faculty of some university, good university, and there should be no illusions. This is a very important level, and we are coming back by closing this cycle. So I would like to finish my presentation by a small illustration. I've been speaking about important level of the client to look at the quantum cryptography, which is a part of quantum communication, which distributes secret keys to legitimate users. But why? Why do we need those keys and their distribution? Those keys, nobody needs them. The keys usually are put into cryptographers, which are decrypting and encrypting information, something which could be interesting to the banks, commercial structures, law enforcement agencies. It's coding and encoding and decoding of the information. This problem can be solved by coders, which are very complex devices with certain characteristics, and it can be regulated by certain legislation, and you have to understand, because it's a very serious topic when the information being encrypted. And I would like to call all of you, and I make emphasis in my presentation, that this particular level of technological development, especially quantum technology, is very important and highly demanded. Thank you very much. Thank you. Our discussion was intended as coming from general vision through the science to applied things, and then to the role of the state. But right now I see that we've been visited by Mr. Dvorkovich, Vice Prime Minister of the Russian Federation. Arkady Vladimirovich, you have 10 minutes, so I will try to change the agenda and ask you several questions right now. Hello? You know, perhaps the question, will quantum technologies be supported or not supported in Russia? But what do we see right now in Russia? We see that there is a certain number of groups, several dozens of those. And the main objective is very important. The quantum computer, maybe it should be solved as a space project that was measured, or as a nuclear project, and the role of the state in coordinating the activities from the side of researchers and from the side of the institutions of development is very important. And perhaps you're the right person. How should we coordinate, and should we coordinate those programs? Thank you very much. I would like to welcome all of you at the Open Innovations Forum. Thank you all for being here with us in the next 2 days. Russian and foreign participants, you always are welcomed to Skolkovo. I think that the answer to this question is resting on 3 main pillars or levels, like it was said previously. Level number 1 is a fundamental level. The state will continue supporting fundamental science, which are critically important for applied, including quantum technologies. And this is the main role of the state in this part. And also will finance and coordinate and give maximum support for all the lines of education, mathematical, physical, and fundamental science. We invest more and more money in these 2 spheres, looking at the leading schools, universities, leading teams, and we do believe that this will bring a feedback, a very positive feedback. And colleagues who are on the stage right now, and some of them are in the audience, I do hope they feel this support. And the second level is creation of the conditions for the constant cooperation between scientific teams, businesses, universities, and state organizations and companies which are interested in applied technologies. Because we do see examples of such cooperation in Skolkovo, for example, between Russian Quantum Centrum and Skoltech University, Skolkovo Foundation, between Quantum Center and Mises University, speaking about third-party universities. It's very easy for me to speak about it because I participate and I'm the head of the supervising committee in both of them, and I know what I'm speaking about. Also, we can see this in many other projects because we are trying to support multiplicity of the sources of support and financing so that we wouldn't have the bottleneck through which not everybody will be able to pass. So we do provide support from the side of the state scientific programs and state projects, and we give signals to our big companies. Speaking about quantum technologies, for example, Gazprom Bank already participates in those initiatives so that they would be involved in this work deeper. We use means from the Fund of Perspective researches and other scientific funds. So we have multiplicity, the full menu of supporting tools that can be used. It's not always easy, it's not always operational without any barriers. Barriers do exist, and we do try to remove them, and we continue working in this direction. And level number 3 is something that we've been speaking about, an attempt to realize specific big projects with a leading role of the state in partnership with the private business and researchers. This is much more difficult because it is very complex to determine the breakthrough direction, and there is a high risk of making an error, a high probability of not catching that key breakthrough direction and maybe lose resources, time, money, and, have a fiasco. That's why a country like Russia is involved in several directions simultaneously, and we will continue doing that, but we will try to provide what we can provide to lead us to success. It is very important to have competencies. Competencies depend on maximum usability of professional expertise because state officials, they cannot determine what is scientifically justified and what is having potential for commercialization and usage. That's why we will try to look at a wider circle of professionals. Well, by saying wider, I don't mean that there's a lot of them, but these are people not only in state authorities and public organizations, but in other institutions and organizations involved in this topic. So this is our approach. And I do hope it's going to bring results. Well, in addition, I would like to ask a question, because you've been discussing about, as you mentioned, about expertise and experts. Very often it happens in joint projects when expertise already has went through feasibility study in European Commission. Does it make sense to apply Western expertise and the outlook from outside to promote or maybe to assess our internal projects? Yes, of course, it's possible. But we will use the assessment of our foreign partners and experts and our own possibilities as well, because we have expertise that already was built in Skolkovo Center. We have expertise in institutions of development like Vnesh Bank is involved in innovation, so Vnesh Bank, Rosnano and other organizations, and we do it on the basis of our joint expert peer committees, which are very successfully being formed in a framework of national technological initiative and also technological platforms which were formed for promotion every specific direction of activities. And foreign expertise is also important, and our own capabilities with the consideration of specifics of those technologies that we're speaking about, because we also should have opinion from inside. Okay, thank you very much. Because in the course of the previous years, we are working with Skolkovo, and I see that Skolkovo, in this sense, organically attracts Western experience and doesn't forget about Russian experience. And the representatives of Russian Academy of Science participate in those meetings, and on the other side, we have respected Nobel Prize winners participating. So it's a great harmony. Okay, thank you very much. Have a good discussion. Good day today and tomorrow and the after tomorrow. Wish you success. Thank you. We have a very interesting discussion, and right now I would like to go back to our scientists and to ask one additional question, and then we will see how can we finance and develop applied science. Mitya has mentioned a case when we've been discussing it, when they've developed the first transistor. You all understand how it has flipped our world. But scientists, when they produced it, they started thinking, why do we need it? And they had one narrow idea how to connect, make a connection between ships in the sea and the land. So very narrow task. Niche market, but in practice, transistor application went outside of those applications that scientists were thinking about. So we are discussing right now, why do we need quantum computer? We make assumptions to solve this and that, but if you look historically, perhaps all our assumptions are very small and narrow, because in real life there will be something totally different. So we should continue thinking about it. And we'd like to turn to Dmitry, and would like to ask Tomas Kalarka, Sergey, Alexei, maybe you will give certain comments about this, because it's a very interesting topic. Why do we need to do that, and how should we do the forecasting of what the quantum computer is needed for? When one of the options of this answer is that it is very difficult to assume what can we use this tool for without testing it in real life. And by testing this real tool in life, you will understand that it can do much more things than you could even imagine in the beginning. And right now, what is very interesting, IBM, for example, 1 year ago, has proposed cloud technology on 5 qubits quantum experience. With the help of this technology, people, scientists and students in the area of theoretical physics from all the countries of the world would receive access and remotely work with this simple 5-qubit computer. And then there was a big number of scientific ideas, works and publications that appeared in this short period of time with new ideas, and it has exceeded all the expectations. So we should learn by doing. When you have something available, then you can immediately think, what else can you use it for? And this process is endless. Thank you, Alexei. During the conference, we had a similar conversation with Misha Lukin, one of the founders of the Quantum Center and one of the most quoted Russian-speaking physicists, the Harvard professor. And when I asked him, Michael, why do we need this quantum computer? He said, I don't know, but let's produce it, play with it, and we'll see, and something will come out of it. And then I would like to jump to another topic. I would like to ask Grigory Trubnikov, you, as a development institution who finances this research, will you be happy about the answer if the ministry will come to you and they will say, we would like to be a quantum computer, but we don't know what do we need it for? So let's play with this. Hello, everyone. As a scientist, I would be happy with this answer, and I completely agree with Alexei that if we're speaking about fundamental science, or at least about first levels of technological readiness, right now it is very fashionable to divide every scientific process in 8, 9 levels of readiness. So if we're speaking about the first 2 levels of readiness, this answer will be sufficient, because in science, negative result is also a result.
We in our country have been successfully implementing several projects in quantum technology, like Moscow State University Advanced Research Foundation jointly with Novosibirsk Technical University, jointly with Rosatom, by the way. Development institutions are actively involved in this area. A number of other projects and Russian Quantum Center. It's my pleasure to praise you if you are too modest. It's a team of the future. A good example of your work is an outstanding conference that you organized in July this year, when you brought all road stars here together in Moscow, and it was an excellent discussion, breathtaking away. And at such conferences we see emerging ideas which cannot be conceived by a single person. An idea or a ready product where quantum technologies can be used, and when you have a critical mass of extra experts, it's an outstanding forum. Well, thumbs up to you for that. It seems that Russia possesses competences, but although I don't like this word, we have at least competence in terms of scientific approach and intellect. And for quantum computers, one of the key things is an algorithm and a task for which this algorithm is created. I think that our institutions, our researchers, our scientists have very good proficiency in algorithm models and in terms of creation of hardware. If you look at Mikhail Lukin as an example, in July it was announced that the largest number of bits in the system was demonstrated by his team. Coming back to the core of your question, the Ministry of Education and Science believes that quantum computers are necessary. And it was mentioned it is not only necessary, not only for science, also needed for education. And by the way, school children, the most advanced of them, I call them cyber scientists. Sometimes they are able to offer more ideas than experienced physicists. Probably for a year or two, based on series or quantorium, we want to organize a competition for creation of several physical mathematical schools plus. It may be an incubator of cyber scientists of the day after tomorrow in their physics, IT technologies, mathematics, and quantum sciences. And I think that we can expect a lot of things from school children. I don't know whether I will be given another opportunity to make a contribution to this discussion. And I will probably add a few words about another initiative that the Ministry of Education and Science, jointly with the Russian Academy of Sciences, initiated pursuant to the presidential decree. In the strategy for scientific and economical development, there is such a thing as comprehensive scientific and technical programs. For quantum technologies, we're putting together two new comprehensive scientific and technological programs that will be 100% linked to quantum technologies, photonics, and the second program is styled supercomputers or big data processing systems. In both areas, quantum technologies are used already, and we're very glad that plenty of people responded to this request and are included in these programs. And I hope very much that the government will support us this year, and the Ministry of Finance will find some funding for us. It's pretty modest funding, not like in China, for example. We'll be discussing participation of development institutions like Внешэконом Bank, Skolkovo, and other partners in these initiatives, because both the Ministry of Finance and Внешэконом Bank are interested in digital technologies in the financial area. I will take this opportunity to invite my colleagues, representatives of different institutions, to join in this comprehensive programs to become full-fledged partners. Thank you. Thank you for your praise. I would like Sergei Gartman, who represents the Advanced Research Foundation, to are you prepared to consider projects where people come and say that we want to test something, will you give us money? Or you use a different approach? We're not prepared for that. Quantum technologies for data processing, which include quantum communications, quantum calculations, are based on an ambitious scientific idea which relies on use these principles to improve efficiency of calculation and confidence of communications. It is a scientifically critical issue. As for applied meaning, the results that we're expecting now may be able to confirm that there is some sense in using these applied technologies. In China they do it, but the speed of transmission is such that expandable block node aboard the satellite will provide secret communications for the duration of active life of the satellite. It will be cheaper by the order of magnitude. Yes, quantum computers and simulators are created, but so far we have not seen a single task which have been resolved with quantum computers and could have been resolved with conventional computers. Probably by the end of the year the situation will change. There should be a degree of skepticism in that. As for ongoing thinking about applied importance of this research is very delicate. We understand that, and based on the relevant documents of the government of Russia, we've created an interdepartmental working group which includes all relevant federal executive authorities and relevant industries, banking sector, and law enforcement agencies. Here, on the premises of this group, we discuss applied objectives, potential applications which may be on the agenda of quantum processing. The systems which are created should possess certain characteristics which may be adjusted. Economic viability of these technologies and such quantum approaches should be discussed and taken into account for the purpose of funding of that or other project. Another thing, there is an expert group which includes leading scientists in this area. Sergei Pavlovich Kulik, it's my pleasure to see him, and Mr. Ustinov as well. And scientists say what in principle can be done by a potential consumer. Not to be too skeptical, I would say that our foundation is funding 3 projects in this area, 2 in communication area and 1 in various calculations. Thank you. we're now talking about organizational matters, how to select projects, how to coordinate activities. And I'm pleased to give floor to Tamasa Kalarka, who is a professor at Norma University. He is also leading European quantum flagship program. It's worth 1 billion euros, which will be starting this year. The underlying idea was the idea of coordination. Tommaso will share his experience of how this thing can be done. How can we rely on European experience to create something similar and well working here in this country?
So I would like to, well, thank you for this question. Thank you for inviting me here. Thanks for coming. I would like to connect to something that Grigory Trubnikov said before. So there is no single person, no single man can do this thing. And well, and there is a lot of excellence here in Russia. Actually, there is a theorem in experimental and theoretical physics. Whenever you give a talk, and there is a question, a problem, which is unsolved in physics, there exists one Russian who solved the problem 40 years ago and published it. And you just have to look for the paper, and some friend of the Russian will show up during the talk and say, oh, but my friend solved this problem already. And this is true, yeah? It's true for every problem in physics, and it shows that there is amazing excellence here. Also, in Europe, we have a good degree of excellence, and the point is cooperation. No one can do this alone. Another important thing, another important story is never leave physicists alone with this. When the physicists invented the laser, they thought, oh, wow, we have a fantastic tool. What can we do to show how beautiful, how powerful it is? And they thought very long, and the first time they presented the laser in public, they invented the following very clever idea. So they blew two balloons, a red balloon, and a green balloon outside. And with a red laser, they blew the red balloon without blowing the green balloon. And this was the most clever thing that those physicists could come up with, which tells you, you better take those devices out of the hands of physicists if you want to do something useful with it. This is the point that we made before, that was made before. We really need for these tools to be available for many people to play with it. And it means interdisciplinarity. It means not just someone sitting in their lab, and the Russian Quantum Center is doing this, a lot of collaboration, but a national program which could be comparable to what we do in Europe should be based on collaboration, bringing together different competencies from different fields, physics, but also mathematics and engineering and chemistry to tell us what are the important problems. Yeah? And also user involvement, user organizations to tell us what are the needs, what is it that society is expecting. And so this is really this value of collaboration that we built our European program upon. And the other aspect that is necessary is, well, it should not be someone's friends, okay? So I fought very strongly with the European Commission because they said, okay, let's do this flagship, now you convinced us, so please give us a big consortium of people and we will give you 1 billion. And I said, not on my dead body, because this is not going to give what taxpayers need. This is not going to give what governments need, only excellence. So peer review, so expert evaluation. You submit a proposal, and there are several examples that have been mentioned here already that is being done in Russia, so this should be extended. You submit a proposal, and then some experts, and perhaps also international experts, evaluate it, and then the best wins. And this is in the interest of taxpayers, in the interest of governments, and in the interest of quantum technologies, because this is the way, via cooperation and excellence, how we are going to get the best out of this field.
Спасибо.
Thank you. Thank you, Tommaso. We have a more sophisticated system now, on top of the state which supports it and on the researchers who do it. We should involve industry for cooperation. Who will undertake the role of the global coordinator? Probably Внешэкономбанк, WEB. It is not by chance that WEB is the organizer of this session. WEB is #1 development institution in Russia. I invited Sergei to give his vision, how to coordinate all the story and to achieve the result that Tommaso mentioned. Yes, really, we decided not to leave this thing in the hands of only physicists. Otherwise, something unusual will happen, and it may be very beautiful, but not realistic. Remember, just physicists created a nuclear bomb, a thermonuclear bomb, and however, it left its footprint on the nuclear industry, nuclear power, etc. I agree with my colleague that it should be joint work. A brief presentation, just a few words. Apparently, I agree with Michio Kaku that quantum technologies is a fundamental area which will change the world. It's a disruptor of disruptors. It is a disruptor which can radically change the vector of movement, not only of physics, but of several sectors, not a variety of vectors. The recent research of MIT, which puts quantum technologies as number 4 in the ranking, which are going to change the technologies in the next 5 years. There is a variety of countries and different sets of technologies, but they are brought together by a single story. What will change in the next 5 years? What else I want to say? Russia should make a leap in quantum technologies. What we are doing now, yes, we have Russian Quantum Center, we have the Foundation of Advanced Technologies, etc., Mr. Ustinov, institutions, research centers, but it is not enough. We should rally our forces. Ruslan said that quantum computers, data processing, quantum centers, these are 3 areas. Sensors are very close to become a reality in our life. There are plenty of technologies which should be commercialized, and one of our objectives is to support such technologies which can be commercialized at the near term.
It's essential that we try to view the global expertise. Intel, Global, IBM are very active in that direction. We visited China. We saw their labs, and they have declared that they are going to have 5-qubit computer. Nowadays, 50-qubit computer. Nowadays, they have 20 or 30 qubits. And we saw the prototype of that computer. And they are investing actively into quantum computers. And in the coming 5 or 7 or 10 years, they will definitely develop it. And they're really very active in communications, and their expertise is unique in that sphere. We really have a great potential, and we put it on a photo with Ruslan as we are really promoting those quantum technologies, and Mikhail Lekin is one of the promoters and really a great researcher in the sphere of quantum technologies. And we have a great deal of work to do. We visited Quantum Center Innsbruck, and 30% of lab researchers are Russian students and postgraduates. And we have a chance to deal with our own quantum technologies and compose our own computer. And we're supposed to launch an initiative and set up a platform which will align all the clusters for computers, for commercialization, for commercial banks, for sensors equipment, and therefore this platform will allow us to align all the efforts. And it will look really similar to what the European flagship is doing, but will be rather more integrated. That is our initiative, and this platform will allow us to proceed in the right direction in the sphere of quantum technologies, and the future is really bright for quantum technologies, and quantum leap will definitely be made by Russia. Thank you for your kind attention. Thank you. Grigory, I promised to give you the floor, and there are quite a number of players at this market, but how to coordinate those programs? We have Niche Econom Bank who are ready to contribute, and they would like to launch a global procedure. And at the same time, we have the public budget with their constraints, and so how to cooperate, how to just make our efforts concerted. How do we go further, from top to down or from bottom to top? I mean from the organizational perspective. Yes, that's a good question. I guess that Evgeny Nikolaevich in his presentation already formulated such an initiative. And I do hope that we are talking about one and the same thing. And we discussed our comprehensive technical programs and what is available nowadays. And we already have some kind of a balanced triad that is made and composed of the R&D sector. They may just launch real fantastic things, but they are aimed at the breakthrough, at the scientific breakthrough, rather than to the application of their methods. And the technologies could hardly be attainable, as well as their algorithms, but they do their work. The second part of the triad is a customer. It is not necessarily a large-scale business or market. It could be also the government. Who is the largest government customer? I guess that this is the Ministry of Defense, the Ministry of Industry and Trade, and Ministry of Healthcare. They have hundreds and hundreds of billions at their disposal, and the customer has to choose what is the best for them and what really has a market potential. Is external or external market. And the third player and the third component part of the triad, and we may call him a regulator or coordinator, that should be the federal executive body. And they are mostly interested in those projects and programs, availability and implementation. And it is their mission to clear the barriers of all sorts, especially legislative ones, so that they promote these technologies and translate them into practice. Alexander Viktorovich has already mentioned the quantum blockchain, the one which we have in Europe, and we really have to speak about MTI, and to set up some kind of a roadmap named Quantum Net. But kind of and those initiatives the government is launching and the roadmap of NTI, so they look different. NTI presupposes large-scale markets, full-fledged circulation and the capture of the global market. And another party is the preparedness of technologies, and they use special funds. And my question is that you really have your own triad, but there could be some parallel one as a part of another initiative. What about the resources duplication? It may happen in this case. So how to make those triads conjugated, and how to align our efforts and not duplicate budget allocations? And the most interested party is the government, but we guess that business should be also of great interest and the government should support it. What do you personally think about it? And in order to align their efforts, they really have to align their efforts and work together. And this particular venue is the best possible way to sit together, discuss it all together, and how to proceed further. We have to be complementary in our efforts and don't duplicate our efforts. And also, it's worthy to mention to collaborate with our foreign partners. And the project we are discussing now with Nishikanon Bank, and this is the Chinese project. This project tends to be a real significant one as a part of the government support. Maybe Sergei has his own vision. Yes, it's really essential to collaborate. But the question arises, what is the difference between the European flagship and other entities? The European flagship, well, thank you, Tomasa, you spoke about it. You spent at least a year in order to set up targets. And it is essential for the platform and to formulate a target. And if we have a 5-qubit computer for a certain year to be launched, and if we're speaking about sensors, really it's substantial for the sector. And in Russia, we have to do the same. Set a task and set a date. And otherwise, it will be hard to proceed in that direction. And another country will invent such a computer, and in 20 years' time, we will purchase it from the other country. No, we really have to just be a part of this process. And, well, we see what's going on in China, what's going on in Europe. And from January, €1 billion was invested for that particular program. And we position ourselves as a very prospective country with new technologies, and we really have to be focused on that as well. So let's set up a target and consolidate our coordinations and be focused on the costs, on the R&D sector, energy sector, etc. And this is a really structural process, and we need to do it via the platforms, but originally the target is to be set. And that's exactly what Europeans are doing, and so this is, we have the similar view. Ivan?
I think it's important to have flexibility because we don't know what's going to be the winner eventually. I think there's a danger in putting all your money in one basket because when the light bulb was invented, hundreds of different kinds of filaments was tested, but finally when people saw that tungsten was the way to go, everybody switched. So I think the same thing here. There are at least 5 different ways of creating a quantum computer. 5. Microsoft, Google, Intel, they're all backing different horses. So I think you have to be flexible because perhaps in the coming decades, somebody will find the right horse. At that point, you have to be flexible enough to immediately switch horses and go with the winner. Because that's what happened with the history of the light bulb. I think we're in that stage now where we're looking at many horses, and we shouldn't put all our money in one horse, but, you know, keep our options open and be flexible.
Спасибо. Спасибо. Я бы тут попробовал объединить 2 тезиса. С одной стороны, надо быть diversifицированным, вкладывать в...
So we have to be diversified or to put a stake onto different horses or just one horse. But we really have to set up the target. But if it's more than one, so the goal will not be attainable. So we have just a couple of minutes left, and let us give a microphone to the audience for Q&A session or to our distinguished speakers. Thank you so much for a very interesting contribution. My name is Yuri. My question is about the average level of preparedness for the launch of quantum technologies and pertinent devices. To what extent they are prepared to leave the lab and to be and go to the industrial scales. You mean the communication of one computer to another, and sensors is the third stage. If we take sensors, and not much has been mentioned about it today. Maybe, Alexei, you comment on that, please. This is a very diversified business area. I mean, the sensors using the crystals, the diamonds, etc. And surprisingly, as it might seem, but these particular substances allow to just witness the micro objects along the magnetic field. We measure the magnetic field, the temperature at the micro level, and that is a very interesting application which is being developed by my company and in the Russian R&D Center. But I really have to elaborate on that subject further, but not necessarily at this particular panel. But depending on various types of technologies, we're coming to different levels of development. So they have to be viewed in a tandem. And we have to keep the balance. Alexei hasn't mentioned a very interesting example from squids from quantum qubits. And already we use the magnetometers, but they are worth $1 million. Not everybody is buying it. But already we have 5 projects available of that sort. And they are all focused on sensors, tools, and commercialization of these particular sensors is our future, and we see it at the level of startups, and some already reach the industrial scale. Altogether, it's not 1 or 2, but 5 altogether. So we are very close to them. Let's ask the girl in the first row. My question goes to Grigory. Will you please specify the entire information you've just highlighted? Tends to be a significant one if we have just the background available. What kind of popularization process is available vis-a-vis quantum technology? Some people are absolutely unaware of the subject, and really we have to find some source of information and realize that it is of great interest to each other. The quantum technologies, quantum mechanics are now studied at school, and how are you going to popularize this particular sector of technology? And at schools, we are not supposed to learn only just classical subject, but some innovative technologies and theories. Thank you so much. In order, actually, we're supposed to have a very good knowledge in physics and mathematics in order to match and be in line and have kind of a profound knowledge in that sphere.
The knowledge that people have acquired in the last 200-300 years. What is being done in this area? Well, let's see. There are a number of programs by the Ministry of Education of Russian Federation in respect to these new projects. And results of these developments on the level of, well, what is being realized by universities, and we're trying to speak about them as wide as possible during exhibitions, forums. Just 1 week ago, Steve Wozniak came to Russia. There was a scientific festival, Science Zero Plus. It's a basic platform. It was Moscow State University, but it was also happening in several federal universities. I don't remember all the names, 6 or 7 universities from Vladivostok and all the way to Kaliningrad. Today, Ruslan discussed this initiative together with colleagues, and we will support this initiative on the basis of series where our best talented kids are coming. We could organize lectures from leading scientists, and we invite school kids from 6th, 7th grade for last years of education in a high school. Right now, in our country, we have approximately 20 to 30 quantoriums. where we speak about these technologies, and the students of first years of university are being told about it. Well, we don't speak enough about it. And in my interviews, I always say that I want my kids in prime time on TV don't watch Ukraine or Syria, but they should watch about achievements of Russian and foreign scientists. You know, it's enough to have 2-3 minutes a day stories shown on TV, and this would be enough. This would strongly, shake the country's brains. And the prestige of science and the place of science in a society would be perceived differently. And we have a lot of things to be proud of and show on TV. Grigory, thank you very much. We do support it. And when there was a news about quantum computer and Michio Kaku and everything else, it has resonated on TV, and there was a big interest. So there is a need, there is a demand, but we also have to accept this responsibility, and we have to all together promote this story. And there is future in it. Please. Hello, Vyacheslav, Ulyanovsk City. Can you tell me, please, where should developers from regions go which already work in instrumentary development, or maybe those who develop quantum computers? Where should we go specifically? Where should we come and say that, well, we have this development, show it, is it interesting or not interesting, do you like it or don't like it? Well, first of all, come to us and we will acquaint you with necessary people. But of course you can come to Bank, FPE, you can come to us, you can come to anybody, depending on the stage of the project. If your project is on the stage, an advanced stage, then you can come to Bank, but together with the Quantum Center, we can look at it. I don't know in which area you have these developments in sensorics, telecommunications, quantum communications. Come to us. You can approach me and I will discuss it with you. Together with Ruslan, we'll talk to you. Okay? Thank you very much. And right now I'm being told that our time runs out. If organizers want to say several final words, we are ready to give you this opportunity. Thank you very much. I would like to say one phrase. Thanks to our speakers, and thanks to everybody who participated. Thank you for your questions. Questions from this lady. The question was very wonderful, because physics in high school ends with Newton physics and a little bit of theory of relativity and nothing else. And, 100 years passed since, 1913, 1917, more than 100 years ago. And we don't tell school kids anything else. Do quantum physics. Teach quantum physics. Thank you very much. Thank you. Thanks to speakers. I think it was interesting session. Nobody has left the audience, so it was an interesting session. Thank you all.